So when it comes to Laplace transformation, we have some theorems. The first theorem says first translation theorem. First translation theorem. This theorem says, well, if you know the Laplace of a function like f of t is equal to f of s, it's already known to you, and a is a real number, a belongs to real set, then the Laplace of e to power at f of t is nothing but f of s minus a. So we have this nice theorem that helps us to just calculate the Laplace of exponential function times f of t. For example, let's take a look at a couple of examples here. Example says, evaluate the Laplace of e to 5t times t cubed. Well, what do we know? We already know that the Laplace of t to the third power is equal to, well, here you have 3 factorial divided by s to power 3 plus 1, which is 4. So we already know that the Laplace of t to the third is 6 divided by s to the fourth. And the first translation theorem says, well, since you already know this Laplace, the Laplace of e to power 5t t cubed is nothing but 6 divided by, you just make a little bit of transformation, a little bit of shift for your s. So s minus 5 to the fourth power is going to be the answer here. Another example. This example says, evaluate the Laplace of, we have e to power negative 2t cosine of 4t. We already know that. We know that the Laplace of cosine 4t is equal to s divided by s squared plus 4 squared. We already know that. The first translation theorem says, well, by knowing that, the Laplace of e to power negative 2t cosine 4t can be written as, well, here you have to make the translation for both s on the numerator and on the denominator. So s minus 2 becomes s plus 2 divided by s plus 2 squared plus 16. So that's how we can apply this new theorem to help us calculate and evaluate different and more complicated Laplace translations.